their stars. Gee whiz, how come? Well, that's because it's tracking a little bit better over there. I turned down the APC to 0 and 1. And what do we get? Perfectly round stars. Oh, here goes the tracking a little bit. So my tracking is not all that good simply because I didn't do a proper 2-star alignment. We're still at 6-second exposure. You don't need any more than that. Although if you want to go more, it's up to a person to do that. And I got no filters. There's absolutely no filters on that. But you can adjust the saturation. You can bring more reds. And here's the other thing that you could do. If you go back into the white balance, go into manual mode and adjust and do the proper balance. So now we have manual 4 on the red, 3 on the red, blue is set at 4. This is 6 seconds, and this is 2 seconds. This is gamma 045. You know what I like to do because of the light pollution of Doddensburg, New York? It's right there on the monitor on the other side. The screen is white. That's how bad the light pollution is. So what we're going to do, we're going to go 8-second exposure and put this to gamma 1. Wow, look at that. Now the brightness set at 100 like I had earlier. We could bring down the brightness a little bit, and we could certainly turn up that contrast to about 60. So bring down the image brightness a little bit, and this is the result that we are having. Now, should we bring a little bit more sharpness? Well, here's what's going to happen. I'm going to put the sharpness of the NCV one from 2 to 7. Look at the center, or roughly the center of M17. We see all kinds of wavy features in there. Wow. Okay, so if we go to APC, what is this going to do? So let's go back to APC 5 on the horizontal and APC 6. Wow, look at that. This looks like a picture perfect just about, and this is live. 8-second exposure, no filter, and I'm pointing directly into Ogdensburg, New York, my worst light pollution by far. I can't even see this on the monitor on the other side because it's all white out of light pollution. So now we're up to 8-second exposure. I could go back on the sharpness and turn that down maybe to 5. There you go. Tracking is better, but if my tracking would be a lot better, stars would be a lot better shape. Now, do we really want it that way, or do we prefer nicer stars? So you need to find out a proper balance. There you go. I've got the APC set at 0 again, and I've got the sharpness back at default of 2. We still got a good image. Stars nice and round, but you don't have the enhancement feature. APC on the camera menu gives you the enhancement on the horizontal pixel and vertical pixels, on the vertical shape of each pixel. That's why you get to change shape of the star. So allow me to explain that. We're going to go to horizontal pixel, and the value goes up to 16 on those. Wow, you see the stars are vertical now, so if you put the horizontal, which is going to squish the stars, look how ugly they look. But did you see the detail in the background of M17? Wow. So if we put back that to 0, the stars have changed shape. If you go to vertical APC and we punch in 16, now the stars are flat. This is a great way to show you this simply because the pixels on those cameras are rectangular, and this is to allow for the lines. The 600 line resolution basically is your amount of odd and even field, so the fields can be matched. So right now the stars are flat because I've got vertical set at 16, horizontal set at 0. However, if I go back to 0, our stars are back to normal. which is round. So you cannot get this type of features on any other cameras on the market. None of them. No USB camera is going to offer you this type of adjustment. Only on a true video camera, an advanced true video camera. These cameras have the built-in computers, the built-in processing, the built-in DSP, the built-in memories, output amplifiers. I could go on and on and on. And here's the other advantages. This is not an RGB sensor. It's a CMYG sensor. It's a huge difference. Makes them very sensitive. You're going to get about 2/3 more sensitivity over an RGB, and you will cover a wider range of colors with a CMYG type sensor. And you're only going to find these in a true video camera sensor, the ICX828 or the ICX829, which is the PAL version. Of course, we're using a bigger aperture tonight. Nonetheless, the fact is the field of view is not too wide. I'm using the MFR5 on there now. If I'd be using this on the 8-inch, for an example, oh boy, we got a really nice wide field of view. But what we're looking at is the actual target, M57 itself. I'm going to bring that up a little bit, actually. Hang on. Hang on a sec. We are going to readjust the focus a little bit. Okay, sounds good, Rusty. Thank you for being here. Lots of fun as usual. Let me bring up the target a little bit higher here, and we're going to go back to 8-second exposure. Have a good night, Rusty. Yes, it is. The skies are gray actually in this direction, because on the monitor on the other side, Lance, you're absolutely right. I cannot see that object in there. I just see a star group more than anything else. But on a computer here, you get to adjust the capture device, another luxury you don't have using a USB type camera. Once you've got that adjusted right, look out. This is a lot of fun. And there's no filters here. The only thing I'm using is the a focal reducer, and that's it. No guiding, no anything. Mind you, next time though, I'm going to have to calibrate my telescope better, so we get a solid tracking, and especially the go-to. The go-to is going to have to improve, because I've seen this scope last week when we did a broadcast go from M15, which is southeast, straight up to M82. M82. Okay, we'll go there next. How's that? That too is low to the horizon, but that's no reason not to be able to go there. But nonetheless, we did 180 degrees with it, and it did find M82 no problem. So I should have done a 2-star alignment. This is my fault, and I have to apologize for that. I don't go through a whole bunch of object broadcasts simply because I like to explain either what we're looking at or what we're doing in order to get a good view with the camera. And you can see the background is not as dark as we would want it, and that is simply because of the light pollution generated from Ogdensburg, New York. This is 045 gamma, and this is 1.00 gamma. And that's not even enough to make the background darker. So you can imagine the light pollution. I'm trying to adjust it here, maybe, see if we could get that going, but it's pretty well the best we could do. Actually, yeah, let's try the Eagle. Good idea. Well, let me see. Well, I hope I'll find it, because your go-to tonight is not that good. So I'm going to do a sync command on this guy. Okay. And how about if we go M16? I'm going to go on the other side, make sure it's going to center in there. And that will be interesting to view. All right, M16 it is. Hang on. I'm going to go on the other side and view this. Oh, there you go. Okay, I forgot to take the integration off. Oh, that's excitement. All right, hang on. Oh, here it is. All right, there we go. That's the one. That's even lower. Okay, this is even lower to the horizon. Wow. Okay. Okay, let's go at 8-second exposure, and we'll try to keep exactly what we had on there. So, as far as adjustment, but we may have to redo it again. So, here comes 8 seconds. Wow. Oh, this is cool. All right, hang on a second. Now I know which star that we're looking at. We're going to raise it up a little bit. Not too much, I hope. And go to the left just a tad. All right, that should be okay. Wow. All right, let's go. Let's try this there, folks. And good suggestion. I completely forgot about that, Lance. I imaged it at fine mount, but okay, there we go. Now, how can we improve this further? We are right into light pollution. And this is no filter, don't forget. This is raw camera power is what I call it. And maybe we're going to need a little bit more exposure. This is 8 seconds at the moment, and let's go maybe 12. I think 12. Oh, by the way, I've got the AGC set to off. I didn't even turn the AGC on yet. This is AGC off. Yeah, that's where I'm going to go. Don't forget, I don't have a filter on this thing here, so here's 12-second exposure. So we had to bump it up from 8 to 12, and we could probably do one of these. Hang on a sec. Okay, my contrast is maxed out, so alright, hang on a sec, just bear with me. Are we on manual mode on white balance? So we got 4 and 4, red and blue. This is ATW, and it's okay, but I'd rather use this guy here, manual mode. Oh, what did it look in infrared? Cool. This is the other infrared. Whoa. Alright. Let's go back to photographic look. This is cool. This is live. 12-second shot. No filters. No guiding. No nothing like that. Don't forget, I'm using a big aperture, and what happened is we are magnifying the stars. So the wider field of view you're going to get, such as 6-inch, 8-inch, or 10-inch, the better the view is going to be, because you're going to get a lot wider field of view, and most likely you'll have a sharper, much sharper images than what we're looking at the moment. Speaking of sharpness, I could always increase the sharpness a little bit, and we get to see a little bit more detail in the eagle itself. Actually, I'm curious to try something. Either it's going to make it uglier or whatever the case is. Let's try it for the sake of experiment. Okay, I just put up the APC to 5 and 6 to see if we can bring a little bit more detail in there. This is very low to the horizon, and I'm right in the light pollution of Ogdensburg, New York. They certainly give us a lot of light pollution here, but still. It's 12 seconds only, so it doesn't matter the size of the scope. What matters is the F ratio. That's very important to be able to get good detail and quick exposures. Oh, this is nice. Very, very, very nice. We see some nice detail in the eagle itself. The pillar of creation right on the tip, you could see some of the variation here. And we certainly could see the star field, of course, is just impeccable. I just wish I was not in the light pollution. This is my worst part of the sky. And I wish I had better tracking. Hey, you can't have it all, and that's the fun part of video astronomy. You're going to get good nights, you're going to get lousy nights, you're going to get very bad conditions, or you're going to get a lot of light pollution like I usually get now, because it certainly has changed in 5 years here. It's getting worse and worse and worse with light pollution. Mind you, when I used to live in Ottawa, I couldn't see this because buildings were in the way, and of course there's lots of light pollution as well. I think I've seen it once between two houses, but it looks okay because it's higher magnification. That's the reason why that you're seeing it the way it is. If you'd be using this on a 8-inch, 10-inch, 11-inch scope, you'd get better results than that. There's no question about it. First of all, the stars would be smaller, not magnified because of the aperture like I have, and also you would get, I would say you get razor sharp look. You would get an improvement on the sharpness of the image. So you'd be able to vary the adjustment that you need to get that. But you still would probably need the same amount of exposure, anywhere from 8 to 12 seconds. This is 12 seconds at the moment. Actually, how about if we bring this up to 15 seconds? I'm just curious, just for the heck of it. And we're going to lower the I'm going to lower the APC a little bit. Yeah, this is nice. This is perfect, just the way I like it. There you go. This is 15 seconds. Look at the difference it made. Quite a lot. Okay, let's bump that up to 18 seconds. Now everything is getting too bright, and you don't want that. Okay, right now it's at 53. Remember earlier it was at 91? 100 or so, 97 to 100. Now it's down to 53. So we're going to go 18 seconds now. I think it is 18. So the brightness on the MCB1 using Stefan software is down to 53 at the moment. Way too bright. So I'm going to bring this down to 25. Oh, now we're getting a better contrast of the eagle with longer exposure. This is a faint object. I don't even know if you could see this with an eyepiece. You can see the star field, but I think you need a filter and an eyepiece to see that. Contrast is 63, which is the maximum. Saturation is at 32, which is default. And the hue is set at 41. And the sharpness at 6. Now, if we lower the sharpness to 2, which is the default, we get a smoother image and rounder stars. Well, I don't want that because I like to see the detail in the eagle itself. So I think sharpness at 5 is perfect. It's pretty good to my eyes anyways. I don't know about your eyes. And APC is set at 3 and 4. Now you can see the stars are flat. That's because my tracking is going from left to right and it's not good. So let's put the APC back to 1. There you go. Stars are still flat more or less because of my tracking going from left to right. Okay, since we're at 18 seconds, how about if we bump that up to 20 seconds? That's why I keep telling everybody, don't go a lot of exposure. When I hear people saying, okay, I got my Xterminator cranked up to a minute. Ouch! I went to 12 seconds earlier with M57, 10 seconds, 8? Yeah, at 8 seconds it started to get overexposed. Back off. If you've got your resin adjustment done right on the on your MCB1 capture device and through the Stefan software, you'll get the same result with Milo Slick, I'm sure. You need to back off on the exposure. You don't need to go long exposure. A good efficient camera does not need to go long exposures, especially when it uses a CCD sensor like the ICX 828 or the 428 for that matter, which is my favorite by the way, and or the 418. I could see the 418 going a bit longer exposure because they're not as sensitive, but the sides are all the same. That's why I like the X-View ad, EX-View ad, not RGB but CMYG sensors, and you're going to get that with the 418, ICX 428, my favorite, and the ICX 828, which is the one I'm using. This is 3200 millivolts of sensitivity compared to the 428, which is 1600, and compared to the 418, which is 1300. So you've got a big difference in sensitivity. Nonetheless, results from the 428 to the 828 will be very, very similar. I think the 828 has the edge, but that's my opinion based on my eyes and what I like to see. So we pump this up here at 20-second exposure. So I'm gonna have to bring down the a little bit of the brightness. So the brightness is down to about 19 at the moment on the capture device. We're getting pretty near the limit, and if it's the case, that's where you go to the back of the camera and flip the AGR, and glow reduction circuit. You're going to lose about 15% of image brightness, but you're also going to lose the anglo, which we don't have any tonight, and you are going to be able to crank up the brightness. It's like having a secondary gamma. So the background gets much darker. Stars are fairly around here, although my tracking is not the best, so when they change shape, it's because of the tracking. But I think we got a nice view of M16 here, the Eagle Nebula. So we started, I believe it's 8 seconds, 12 seconds, and then went up to 15, yeah, 12 seconds, 15, 18, now we're at 20. It's pointless to go any higher than that. I'm right in the light pollution of Ogdensburg, New York. Okay. Hang on a sec, folks. I want to go somewhere. I don't know if the scope's going to go. I hope it does. And allow me to see if we could get there. Okay, now I'm back at 2 seconds, but I need to bring the brightness up. And you could actually see the eagle. So when you look for an object, or if you're going to center an object, 2 second exposure is all what you need, providing you crank up the brightness, which is 73 in this case, and the gamma is at 045. Alright, let me go look for M82. I hope we'll be able to get it. I hope. If we don't, I don't know what I'll do. Anyways, let's go get M82. I'll be right back.